A particle moving with velocity v is acted by three forces. The vector triangle PQR. The velocity of the particle will remain constant. Coefficient of sliding friction has dimensions of length. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time T1 on the other days. If she remains stationary on the moving escalator, then the escalator takes her up in the time to T2. The time taken by her to walk up on the moving escalator will be T1 T2 by T2 plus T1. Two astronauts are floating in a gravitational free space after having lost contact with their spaceship. The two will move towards each other. A rigid ball of mass m strikes a rigid wall at an angle 60 degrees and gets reflected without loss of speed. The value of impulse imparted by the wall on the ball will be mv. A car is negotiating a curved road of radius r. It is banked at an angle theta. The coefficient friction between the tires of the car and the road is mus. The maximum safe velocity on this road is root gr into mus plus tan theta by 1 minus mus tan theta. The upper half of an inclined plane of inclination theta is perfectly smooth while lower half is rough. A block starting from rest at the top of the plane will again come to rest at the bottom. If the coefficient of friction between the block and lower half of the plane is given by mu is equal to 2 tan theta. A block A of mass m1 rests on a horizontal table. A light string connected to it passes over a frictionless pulley at the edge of a table and from its other end another block B of mass m2 is suspended. The coefficient of kinetic friction between the block A and table is mu k. When the block A is sliding on the table, the tension in the string is m1 m2 in brackets 1 plus mu k into g by m1 plus m2. A balloon with mass m is descending down with an acceleration a, where a is less than g. How much mass should be removed from it so that it starts moving up with an acceleration a? Answer is 2 ma by g plus a. A car of mass m is moving on a level circular track of radius r. If mus represents the static friction between the road and tires of the car, the maximum speed of the car in circular motion is given by root mus into rg. A block of mass m is in contact with the cart C. The coefficient of static friction between the block and the cart is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. So is alpha is greater than g by mu. Sand is being dropped on a conveyor belt at the rate of m kg per s. The force necessary to keep the belt moving with a constant velocity of v m per s will be mv Newton. A block B is pushed momentarily along a horizontal surface with an initial velocity v. If mu is the coefficient of sliding friction between B and the surface, block B will come to rest after a time. Answer is v by g mu. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by the wedge on the block, here g is acceleration due to gravity, will be mg by cos theta.